All right, so evidence number one, definition of functional requirements for the sensor and actuation system and choice of commercial equipment. So basically the description of our application, so we have a curtain or door that must open and close manually and automatically. The door should have configurable speed, 3 to 5 seconds. It should be able to be held in place at a desired height using a brake system. It has to have a configurable user interface, a safety system, and some general information about our curtain. It's going to be from 3 to 4 meters. Its height's going to be 3 to 4 meters. Its width is going to be 3 to 7 meters. The weight on average of the curtain is 900 grams per square yard. And to ensure tension, some metal bars are attached to the curtain. And these bars will have a mass of 17.5 kilograms per meter. So anyways, that's this description of our application. Just basically a door that must open and close automatically and manually, safely, and that's pretty much it. So the sensor system. So basically, sensor system must be able to provide the controller with data on the physical variables. That's basically what every sensor system should be able to do. So yeah, that's a sensor system. So, but our sensor system should be able to tell us current height, angular velocity, velocity of the current, acceleration of the current, and distance the current must travel. So to do this, we pretty much decided on 3 main sensors: an inductive sensor, an absolute encoder shaft, and a photoelectric proximity sensor. So we were thinking of using the inductive sensor base, and all these 3 sensors are pretty inexpensive. But anyways, we were thinking of using an inductive sensor basically to set limits to protect our machinery, and also for when we enter automatic mode. So basically, an inductive sensor, how we planned on it working would be, and how I'm pretty sure they all work, is on a true or false or high or low voltage sensor type, where when they're activated, they send a true signal, and when they're not activated, they send a false signal. So obviously, when our current reaches a certain position, the inductive sensor would send true, and thus stopping our motor, or stopping the actuator from sending force to the door. So basically, yeah, we're gonna have we're gonna place those at the max and minimum position that the current can pass. And basically, this would be good for automatic mode too. So like once the automatic mode is started, we can make it so it goes to the max and minimum, and that can be easily read by an inductive sensor. And so the absolute encoder shaft, that would be if we were going to use that basically to get absolute position of our curtain, just more information, and also speed, obviously, because we're going to need that, because obviously we need to be able to speed it up or speed it down, and absolute encoder shaft would be great for that. And a photoelectric proximity sensor, basically for safety. We don't want anything to be where it's not supposed to be, so we're gonna put those where we need to, just to avoid people from being underneath the curtains, or from anything being underneath the curtains, and just protect the curtains and protect the people working them, or people in general. And so basically, this is a sensor system we thought we had in place, or we want to have in place. And obviously the PLC, we're going to need a controller to read these signals, push buttons, like these signals from the push buttons or from the sensors, because obviously the current is going to work on a button type of automatic. You press a button, manual, you keep pressing the button, and it's going to send an output to the motors. Anyways, so talking about motors, the actuation system. So basically, the motor is the most important element of our system, and this motor is going to be, it should control the movement of the current upwards and downwards. It should be able to stop when the brake button is pressed, and it should stop operating if the on or off buttons are pressed, and should be able to modify speed. So, and the actuation system shall be able to receive parameters for an automated process. So yeah, so automated actuation system and the sensors. You need both of them. But yeah. So here we calculated using some basic equations on what our velocity should be, or do like what our power and force and work should be with max values and minimum values. Minimum values would be lower weight, lower speeds, and max values, higher speeds, higher weights. What our motor must be able to supply. Um, the work the motors must be able to do to move the door. And we found this cheap 1 horsepower motor. Well, not cheap, they're like 3,000. They're still like 3,000, 4,000, maybe even going on sale for 2,000. But here we can see the specs of it. Tension, velocity, rotation, potencia. So yeah, that's going to be in charge of controlling our door. And now personal reflection. So basically, this door seems or I keep on calling it a door, but it's curtain. This curtain is complex and not really at the same time. It's really interesting how all these elements have to work together to get the door to open and close properly and safely, and be completely I don't want to say completely modifiable, but you can control some of the aspects of it. And to do that, you need a lot of ingenuity, because a lot can go wrong in mechanical design, and you have to be precise. So I think that's really cool how something as simple as a door opening up and down, it takes a lot. And yeah, it's very fun, very, very interesting. I'm glad I chose this as a career, because the more the more you read about it, the better it gets. So I don't know, I'm gonna stop right here.